Namaste everyone. Thank you for all the support, all the love you are showing to my channel first of all. Now in this lecture, we are going to again take a machine learning based project. So let me first rename my file to diabetic and non-diabetic. So the project which we are going to do today, with this, anyone can find out whether a person is a diabetic or he is non-diabetic. Right, so I have a data set with me. Let me just show you that data set first, in which I have all the data features stored which we'll be using for this machine learning based project. So basically this is the data set with which we are going to train our model, and also we are going to test the performance of the model. Right. So let me just show you the data present in the data set. And besides that, there are number of courses which I'm offering right now to the students. So there are courses related to web development. There are courses related to game development, application development. Then there is mobile application development, desktop application development, Android development. I have courses, related to things which are right now multinational companies, professionals are using for developing applications like Uber, right? You must have heard about React.js, Node.js, AngularJS. So, if you want to learn all these things, you can take my coding classes. Definitely, you will take away many things from those classes, and hopefully you will get a job in a multinational company like Google, Microsoft, once you are done with getting the training from me. Okay, so that's the data we have in this diabetes named CSV file. So there are these parameters which are right there on the top of this Excel table. I hope they are visible to all of you. Right, so we'll be using this data for testing purpose and also for training our model. So let's come back on Google Colab. I hope you guys know about this platform. It's a free of cost online platform on which you can, use Python coding. You can also use R coding on this. So just try out this platform. Definitely, it's a very good platform for machine learning, for artificial intelligence. You're going to enjoy it a lot. So let me come in this very first cell and let's import all the packages that we require for this project. So we require NumPy, right? Pandas for reading the CSV file which I just showed you. Then there is this standard scalar function that we'll be using for standardizing the format of the data present in the CSV file. Then there is this function called training testing split, which we'll be using for splitting the data into two parts, training data and testing data. Then we'll be using this model called SVM. Full form of SVM is support vector machine. And we'll be using this model for this machine learning project, and with accuracy score we are going to check the performance of our model. Right, let's run this code. So you need to click this play button for running the code, and let's see what we will get. The code is being executed by Google Colab right now. We'll have to wait for some time. Uh, okay, so Google Colab successfully executed all these lines of code, which I just copied and pasted here. Let's import the CSV file. So for that, we can right click here, and you'll get to see a cascading menu like this, in which right on the top upload option is present that can be used for uploading the CSV file, in which the data and all the features are present with which we can train and test our data. So it's there in grade 10 name folder and ML projects, and inside diabetic non-diabetic I have the CSV file in which all the data is present. So let's hit this OK button. Okay, so the CSV file is here now. We can use it for our model. Let me close the window. Let's create another coding cell, and I'm coming back on this notepad file. So it's time for us to load the data, right? And we can use this line of code for doing that. So PD is for pandas. As you can see here, we have imported pandas as PD. So it's basically an alias we have created here for the library pandas. And inside this PD, we have a function called read CSV, with which we can read the CSV files content. So let's execute this code. Okay, the code got successfully executed. Let's create another coding cell and let's pull the first 5 rows. Let's pull the data present in the first 5 rows of this CSV file, and that's how we can do it. Head is a function, right? And you can see the data is here right now. Let me just show it to you. Okay, so that's the data present in the first 5 cells, first 5 rows of the CSV file. So it starts from 0, right? The index number starts from 0, as you guys know very well, and we are able to pull the data of first 5 rows. These are all the features which are getting reflected here, and right on the top in the very first row we are able to see the uh, parameters, right? Okay, let's let's add another coding cell. Okay, we need to add a coding cell here. Sorry, yeah, perfectly fine. And now it's time for us to find out the shape of the data set. So that's the function we can use for doing it. Shape. So it is 768 by 9. Right, it's saying 768 by 9. Let me show you why it is giving us this output. Because in total there are 768 rows, right, and there are 9 columns. 1 2 3 4 5 6 7 8 9. That is the reason it has given us this output. Let's create another coding cell, coming back to the notepad file in which the codes are there. It's time for us to now get the statistical measures of the data. So I hope you guys know about this describe function. If you have learned machine learning earlier, so you must be knowing about it. If no, then you can check out the lecture which I shooted and posted yesterday on my channel. In that also I used this describe function. Basically it helps us with these things which are very important for machine learning model. So it gives us the count, the mean of the data, then standard deviation, minimum value, 25%, 50%, 75%, and then maximum value. So all these things you can get with the help of this describe function. Let's create another coding cell, and coming on the next line of code. So with the help of this, we are going to calculate the number of examples we have in this CSV file for the diabetic cases, and the number of non-diabetic cases we have in the CSV file. So we can run this cell, and as you can see, number of non-diabetic cases are much higher in comparison to the number of diabetic cases. So in total there are 768 cases, out of which 500 are of non-diabetics and 268 are of diabetic. Let's create another coding cell, and coming back on the notepad file. It's time for us to group the data on the basis of mean. So let's do it. So as you can see, the people who are non-diabetic, right, their glucose is 109.98 something. But the people who are, diabetic, their glucose is somewhat high. So, from here you can just predict that who on the basis of the glucose reading, who can have diabetes and who is a non-diabetic. Okay, let's now separate the data. So we are going to make use of these two lines of code. So what this first line of code will do for us, it will take all the columns. Okay, it will take all the columns into consideration, except the last one. It's written x is equals to 1. Let me just show you the data first. Coming back over here, yeah. So you can see the last column has the labels in it. 1 refers to diabetic case, 0 refers to non-diabetic case. Right, and what this thing, it's written here, columns is equals to outcome, x is equals to 1, drop. So this drop function will drop this column, right, and it will take the data of all these columns and will feed it as a value to this variable x, right. And y here we'll be using for the outcome. Okay, so these labels will go in y, and the data and the remaining data will go in x, right. Let's execute the cell. Fine, let's create another code cell and let's print the value of x and y. So what do we have at present in the variable y and the variable x? So let's check it out. So we have in y all the labels you can see here, and in x we have all the values, all the features, right, which we have in the CSV file. Let's create another code cell. Coming down, it's time for us to now standardize the format of these values. So you can see here the values are like 6, 1, 8, 1, 0, 183, 89. They're more than one. Okay, now if you want to bring them, if you want to standardize these values, so for that we can make use of standard scalar function. So this is what I'm going to use now. Let's just put it here. I am executing the line of code. So Google Colab successfully executed it. Now let's fit the data we have in x, let's feed the data we have in x to the standard scalar function we have saved in this variable named scalar. Okay, so it got successfully executed as you can see. Now it's time for us to transform the data, right. So in this line of code we fitted the data, and now we are transforming the data to a standardized format. Let's do it. So scalar dot transform, right. Let's execute this code thing again. Now I'm going to print the data we have in variable standardized data. Let's see what do we have in standardized data. So you can see here now all the values are between 0 and 1. There is no value which is greater than 1. So it will be now easier for the model to find out whether a person is diabetic or non-diabetic, because in the outcome the labels are in the form of 0 and 1. Okay, so that is why the standardization of data was required. Now let me just print the value of x and y again. So sorry, let me give the value of standardized data variable to the variable x, and to y the outcome is already there in it. So I'm again executing this line of code, no problem. Let's print the value of x and y. So here I go. Let's see what we have in variable x and y. So in x now we have all the data features, the values of which are somewhere between 0 and 1, and in y we have all the labels. So 0 is for non-diabetic and 1 is for diabetic person. Let's come down and see what we have next to do. So now we need to split the data into two parts, and that's the code we can use for it. So here what we are doing, we are using train test split function for splitting the data into two parts. So point 2 is written here because I want to give 20% of the total data to I want to take 20% of the total data as a testing data, and rest 80% I would like to take for training my model. You must be knowing that the more data you will use for training your model, more accurate it will give you the result, right? More accurate will be the result which the model will predict for you or will give you. So 80% I am going to use for training the model, and 20% I will be using for testing it. Now stratify is equals to y. Why I have used stratify here? Because I want that testing data and training data should be splitted evenly, right? That is the reason I have used stratify here, and you also will have to use stratify if you want to evenly distribute the data between the two categories. Remember this thing. Okay, then we have this thing called, there are four variables here: x train, x test, y train, y test. So the data we have in variable x, which is all the data features ranging between 0 to 1. So they will get splitted into two parts. The first one is going to be the training data features, and the second one is going to be the testing data features. So the training data features will come in this variable x train, and the testing data features will come in the variable x test. Similarly, the outcome values, that is, the labels 1 and 0. So they will get splitted into two parts. The training one will come in y train, and the testing one will go in y test. Let's execute the line of code to split the data into two parts. Okay. Let me now check the shape of these three variables. So x is the variable in which we have all the data features saved. X train is a variable in which we have all the data features with which we'll be training our model. And x test is the variable in which we have all the data features right now with which we are going to test our model. Let's execute the line of code and see what it will give us as the output. So you can see here, okay, we are getting this as output. 768 is the total number of cases we have, and now 768 have been splitted into two parts. X614 is given to the training data set, and 154 examples or features we'll be using for testing the model, right? So it's perfectly fine. Now let's come down and initialize and call our model. So we'll be using SVM classifier for this machine learning project. SVM stands for support vector machine, right? and let's execute it. Okay, so the code got executed successfully. It's time for us to train the support vector machine classifier. So we'll be using the training model, training features and the outcomes we have in Y-train for training the classifier. And here we go. Okay, we successfully trained the model. Okay, let me just come down. I'm scrolling it down. Fine. Let's now click this code for creating a new code cell. It's time for us to ask the classifier which we just trained with the training data to make for us some prediction on the basis of the training data. So we'll be using the training data first on the model, and then we'll be using the testing data which our model doesn't know anything about for checking its for evaluating its performance. So let's first evaluate its performance on the basis of the training data set which we fed to the machine over here for training it. Let's see what it will give us for the data which it has the information already about. So we need to execute this cell. Fine, the cell got executed successfully. It's time for us to see what we have in this training data accuracy. Okay, so as you guys know very well, this will give us the performance percentage. So it is 78%, which is quite nice, right? So our model is is good to go. Let's now test the model on the basis of the testing data. So it doesn't know anything about the testing data. Okay, I'm going to now test the model on the basis of the testing data. Here I go. So I think we'll get the correct output. Okay, we need to print the value of test data accuracy named variable in which the accuracy score is there. So let's execute this line of code. Okay, so our model's performance is 77%, right? So it's a very good model and it's working properly. Now let me just show you something, and I would like to paste all this code over here. Okay, let's now check whether let's now assume that we have trained our model, we are done with testing our model, and its accuracy score is 77%. So now we can deploy it in that environment for which we have created it. So we have created it for finding out whether a person is diabetic or non-diabetic. So what I am going to do is I'm going to take some features from here. Sorry, just a second. Yeah, I'm taking a random feature from here. Okay, and I need to close the CSV file first because it's not in the comma separated format. The values are not in the comma separated format. I need to open it in Notepad for seeing the data in a comma separated value format. Open with, and here I go. So this is a comma separated value format. Let me take this one. So you can see for these features the outcome is 0, which means the person is non-diabetic. Let's feed this data to the model and check whether it will be able to give us the whether it will be able to give us the correct output or not. All right, let's check out the predicted value. So what we have done here, we are feeding the data features to the we are feeding the data features to this variable named input data. Then we are converting it to an array using numpy. We are reshaping it, right? And then we are transforming it. You guys remember we use a transform function on the top, right? So it will be transforming the data present that we have passed here, right? And finally it will be fed to the classifier, that is svm classifier, right? And then it will print, we then will be this, then this line of code will be printing the prediction of the model. And if the prediction is equal to 0, right, so it means that the person is non-diabetic. And if it is not, then the person is diabetic. Let's execute the line of code and see what we will get as output. Okay, so it says person is not diabetic. That is absolutely correct. Right, he's a non-diabetic person. Let's check out some other examples. So I'm taking this one now. For this, the outcome is 1, which means the person is diabetic. Let's feed the data features to the model and see whether it will give us the correct prediction or not, whether its prediction will be correct or not for the data feature. Okay, let's execute the line of codes. So it says the person is not diabetic, so it's not correct. Let me just, I think I haven't copied the complete row. Maybe that's the reason. Let me check for these features. Okay, I think, yeah. Is it fine? Is it fine now? Let me check once again. Okay, let me execute the input data. So it says person is diabetic, which is absolutely correct, right? We copied this code, and for this, the person, the outcome is 1, and yes, the person is diabetic. So, that is how you can, with the help of machine learning, find out whether a person is diabetic or a non-diabetic. I hope you guys enjoyed this lecture a lot. Please do not forget to like and share the video in your groups so that it can reach to the maximum students possible. Definitely, these videos are going to help every person who is learning machine learning or who wants to learn machine learning in a very good way. Right, and in case you want the coding classes, you can contact me on the number below. I am reachable on WhatsApp also on this number. Thank you very much for liking the video, for sharing the video, and also for showing the love and support to my channel. Bye bye and have a great day, everyone. God bless you all.